Hi, I'm Jude Niroshan. Welcome to my Java programming course. In this video, we are going to learn everything about arrays and collections in Java. This video is part of a complete Java course I have published on YouTube. If you are interested in becoming a Java expert, I would encourage you to check out the rest of the videos as well. Java language have 8 different primitive data types. When you do not provide a value for a primitive data type variable, Java will assign a default value. Here you can see I have shown you all the default values for the respective data type. If you look closer, most of these values are neutral, and all the numeric data types has the default value as 0. Here we have 5 variables. All of those variables are from the integer primitive data type. It is also possible that we can group all of these 5 variables into a single variable. That is what we call as an array in Java programming language. The array concept is a very known concept even among other programming languages. Here I have shown you I have compressed all those 5 variables into a single structure. And in fact, it is a single variable. I call the variable name as numbers. This is the array structure. You can store multiple values inside this array structure. Data values inside the entire array object has to be from the same data type. When you create an array, you cannot expand or shrink that array size. It is a permanent size of structure that you cannot modify later. I cannot include another block or another cell into this array which has only 5 different cells. The length of an array is a permanent number. I cannot even reduce or I cannot even add new blocks or cells into that array object. Here is the complete syntax to create an array. Just like we created variables or objects, we have to start with the data type. And then we provide a variable name, we use the equal sign and then assign the array that we have created. Pay attention that I have used the new keyword to create an array. Whenever we create an array object, we must specify the array symbol in the data type. And also when we are creating the array object, we have to specify the size of the array. The size of an array is how many cells or how many slots we need inside that array. When we ask Java to create an array, Java internally go and reserve the number of slots according to the size of the array you have specified. In this case, I have requested integer primitive size of 5 array. So Java will create an array with the size of 5 different slots in that array. And every individual slot or element in that array has a unique identifier. That is what we call as the index of an array. Don't forget that index numbers start counting including the number 0. When Java creates an array, it has to initialize the values for individual position. That is where the default values comes into play. Every individual value will be assigned to the default value according to the data type of the array. So in my IntelliJ IDEA, I have created a new project called data structures. Inside the main method, I have created 3 different integer primitive variables. These are the marks that I have for individual subjects that I have took in the school. All these 3 variables are from the same data type of integer primitive. Since we know about Java arrays, we can create a single Java array to store all these 3 values. Shall we print this grades variable into the terminal and observe the output? Here what you actually see is a reference value. It is not the object and the internal values in that object. That is because any array is an object in Java. If you can recall, we have primitives and objects in Java. Arrays fall under the objects category. If we look closer into this array that we have created, what we requested was integer primitive array type of 3 slots. Every individual element inside this array has a unique identification. That is what we call as the index. I hope you remember that the index always starts with the including number 0. So let's utilize the index and access every individual position in that grades array. Here you can see every individual position has the value of 0, which is actually the default value for integer primitive. Therefore, we can say inside this array, we have 3 integer primitives that are being all assigned to value 0. Using the index, we can directly access any individual slot as we want. So let's go ahead and assign the values for every individual slot in that array. Here you can see the values have been assigned to those every individual slot. If we try to access a non-indexing index, we will get an index out of bounds exception. If we look into our grades array, we actually have only 3 slots. And then if you look into the index labeling, we started with the number 0. Therefore, the last element has the index of number 2. There is no third index position for that array. Even though we have 3 elements, we do not have an index position of 3 according to the index numbering. When you create any array in Java, there is an attribute attached to that array object called length. That will give us the size or the length of that array object. Here you can see the array length is 3. So this length attribute is available for any array object you create in Java. There are 4 different syntactical variations you can make when you are creating an array in Java. The first one is we already looked, where we have to specify the length of that array. Since I provided the exact values that has to be inside that array, I should not have to specify the length of that array. Since Java can figure out the size of the array, you do not have to provide this number here. And if you try to provide this number, it will not compile. In the third variation, we have completely ignored the new keyword along with the data type and also the array symbol. We simply use the curly brackets, and inside the curly brackets, we provided the elements that needs to be stored in that array. The last variation is actually coming from the C programming style. Therefore, we call this as a C programming style array declaration. However, it is not possible for you to place the array symbol inside the variable name or before the data type. It has to be after the data type or after the variable name. Like I was telling you that any array in Java is actually an object. Therefore, it is possible that you can create an array and assign it to an object reference type variable. Because any array in Java is actually an object. It is also possible that you can create arrays of custom data types or object types. Let's go ahead and create an string array object. If we try to print this array object, what we would see is actually a reference value. Here you can see what we see is a reference value because any array is an object in Java. Let's utilize the index to access individual elements in that array. Now you have a solid understanding about arrays. You can either create primitive data arrays or object type of arrays. Now, I cannot teach you about collections framework unless you know about the wrapper classes in Java. Every primitive data type has a corresponding Java class. Since we have 8 different primitives in Java, we have 8 different classes with those corresponding names. Here I have shown you all the 8 different primitives along with their class names. We have a special name for these 8 different classes in Java. We call them as wrapper classes. It is important that you understand the difference between the primitive data type and the corresponding wrapper class object type. Here I have took the integer primitive along with the integer wrapper class. Once we create a primitive variable, Java allocates a specified number of bytes for that particular variable. And that value that we assign for that variable will be directly stored in that allocated space. However, when we are talking about wrapper classes, it is just like any other Java class. We create objects out of this class and store the reference inside the reference type variable. Java can magically transform primitives into the corresponding wrapper class as well as the wrapper class into the corresponding primitive data type. We call this special transformation as the auto-boxing and auto-unboxing because Java will automatically transform according to the variable data type. When you are developing large complex software solutions, Java arrays can be a limitation. Because Java arrays has a big problem. The length or the size of the array is a fixed value. That is why Java developers have created this entire Java collections framework which has eliminated the size or the length of the array problem and also added many enhanced features. Using the collections framework, you can easily develop highly complex software and you can manipulate multiple or collections of data values very easily. Let's imagine the collections framework is a huge building and this building is built on top of these 4 pillars. These are list, set, queue and map. All these 4 are Java interfaces. If you can recall what is an interface, it only defines the method signatures. You can walk alongside with me and I will show you every single place inside this collection framework. However, there is a special rule that no one cannot break. That is, you cannot take primitive data types into this exploration. Yes, that is why I taught you about wrapper classes. If you want to take any primitive data type along with you, you can simply wrap them and you can bring them along with you. So let's go. From the collections interface, we have inherited child interfaces. They are list, set, queue. So you can understand now the methods that are defined inside the collection interface will be inherited to all these other child interfaces as well. Map is also a Java interface. However, there is no inheritance relationship to the rest of the interfaces that we discussed. The first Java interface that we are going to explore is the list interface. There are multiple classes that implements this list interface. For example, ArrayList, linked list, copy on write ArrayList. There are many other Java classes that implements this list interface. Lists are very similar to the arrays in Java. However, there is no problem with regard to the length or the size of the list. List can dynamically grow and also shrink according to the available elements in that list. In this case, we do not have any elements inside the array list that we created. Let's add few elements into this array list object. Here you can see once we have added the elements, they are appearing according to the order that we have inserted into the array list. Also note that it is possible that we can include or insert duplicate elements, just like in the arrays. We have used the add method to insert the elements into the newly created array list object. It is also possible that we can retrieve the elements by the index. Here you can see I have removed the apple element. In this case, you can see the first element has been already removed. When we are using the remove method, it will only remove the first occurrence of that element. In this case, you can see the last apple element is still inside the array list object. We can also get the size of the list using the size method. We have 3 elements in the array, so you can see the size returns the 3. Since the ArrayList class has implemented the list interface, we can actually assign the ArrayList object into a list type reference. Make sure to import the java.utils interface. Here what I have done was I have created a new ArrayList object and assigned it to a reference with the type of list. Here you can see the elements have been properly added to the list. However, when you look at this list object, we have added 3 different data values. The second and third cases, that is where the auto boxing happens. The Java will take this primitive value and wrap it into a double representation. For example, I can take this value and call double the value of and then pass the value here. So this transformation will be done automatically by Java. That is what we called as the auto boxing. Same goes for the Boolean value as well. If we look closer into this data that we have added into this list object, they are from 3 different data types. It is very difficult for us to work with such list because we do not know exactly what type of data value we are going to read. That is why in Java 1.5 they have introduced this variation when it comes to defining a list object. With this notation, we restrict that any element that we are going to insert has to be from the type of string. Now it is not possible for me to add any other type of data because we have restricted our names list only to include string objects. In Java 1.7, there is a slight improvement to this particular notation. When we are creating the object for this list interface, we do not have to provide this particular type here because Java can figure it out by looking at the reference type. So we can omit this here and it looks like a diamond. So we call it as the diamond operator. However, you cannot remove this type here because whenever you are using this diamond operator, you must specify the type of every element's data type. The reason why we recommend to use the interface type instead of the class type, it is because later or in future we have more flexibility. For example, if you decide later not to use an array list but use an linked list, you can simply make this change. Here you can see I have changed from array list to linked list. And you can also note that rest of the codes did not change. That is thanks to the reference type, which is the list interface. The second Java interface that we are going to learn is the set interface. Similar to the list interface, set also extends from the collection interface. Set in Java represent the mathematical representation of the set, which is basically you cannot have copies or duplicate elements inside a set. Every element inside a set is a unique element. And also note that there is no ordering guaranteed for the elements inside a set. That means time to time when you are iterating or when you are reading through the elements, the order cannot be guaranteed. It can be changed time to time. Therefore, set do not maintain an order, and also the elements inside the set is guaranteed to be unique. There will be no duplicate or copy of elements inside a set. Let's explore the set. I'm going to create a variable called friends with the type of set. In this case, I have to import the set interface. You can see it is coming from the java.util.set. That is an interface. So now I have the variable name. After the variable name, we have to use the assignment operator. After the assignment operator, can I simply put any value? No, because this 43, it's a primitive data type value. And my variable type is actually from the set type. So the value has to be complied a variable data type. In this case, it is an object data type. However, I cannot simply write any kind of object. In this case, it will not be compiled because the object class, which is the root class in Java, does not comply, does not satisfy the set interface implementations. Therefore, you cannot put any class that you like. This has to be a class that implements the set interface. But what are the available classes that implements the set interface? There are two mainly used ones. The first one is the HashSet class. This is already available inside the JDK. You can simply import it and use it in your Java classes. My variable, friends, it's the type of the set interface. The value that I have assigned after the equal sign, it's the object that I have created from the HashSet class. So this is an HashSet object that I have created. Let's see how this friends set looks like. Here you can see it is an empty set. You can use the add method to insert or add elements into this set. Now, when we look into this example, the elements that we have inserted are from the three different types. The first element we have inserted is actually the string type object. The second element, it's actually the integer wrapper class object. The third one, it's the Boolean wrapper class object. Because you know, any primitive that has been directly inserted will be magically transformed into their wrapper class object representation. The values inside this set are from three different types. This is very difficult when we are writing programs because the values are not from the same type. You will oftentimes face the class cast exception because we do not know at runtime what type of object we are going to read from the set. So let's utilize the generics or the diamond operator in this case to restrict the type of the objects that can be inserted or stored inside the set object. So now we have limited or restricted the types of elements that can be inserted into this set. In this case, we have restricted to string type objects. I have tried to insert this string Jude 2 times into the set. However, inside a set, you can keep only unique elements. In this case, there will be no duplicate elements inside a set. That is why when we try to print the friends set together, we do only see two elements because Jude has been added 2 times. However, inside the set, you have only unique element. Let me add a single space here. Now let's try to run the program. Now you can see we have 3 elements. However, the last element we have added here is including the space character. Let's try to read the values. However, when it comes to set, you do not have the get method like in the list. So there is no get method. You can directly access a single element. So make a note, whenever you are dealing with a set, you cannot possibly access a direct element from that list. The only possibility that you can read a set is through looping or iterating through every object inside that set object. Here you can simply write a for each loop or any other type of loop available in Java and then iterate through that set object. You will find every element inside that set. However, there is no ordering guaranteed. In this case, we are going to iterate through the friends set we created. And then for every element with the type of string, that is thanks to we have specified or restricted the types of the elements inside that set. Therefore, we can confidently say every element is a string type object. Here you can see the every individual element, I have turned them into uppercase English text. If you want to remove an object from the set, you can simply use the remove method. Here you can see I have removed the Jude string with the space. Here I have removed this element. Now I have only 2 unique elements inside the set. It is possible that you can verify a given element is inside the set or not. That is thanks to the contains method. So here I tried to check the Niroshan string is available inside the set. You can see the value returns false. However, if I try to check for an existing element inside the set, I will get the value true because the element available inside the set. The third Java interface that we are going to learn is the queue interface. Just like the list set, the queue interface also extending from the collection interface. You can visualize the principle behind a queue basically just like inserting elements into a pipeline from a one end, and you are reading those elements that are inserted into that queue from the other side of the pipeline. So you can understand the first element that has been inserted to that pipeline will be the first element that you are going to read from the other end. So this is the main principle behind the queue interface in Java. Let's create a queue and observe the important methods. I have imported the queue interface. I'm going to use the diamond operator and restrict the elements only to be inserted with the type of integer. In this case, the ArrayDeque class implements the queue interface. That is why I was able to create an object out of the ArrayDeque class and assign it to a reference with the type of queue. In this case, our queue object can store only the integer type of objects. When we want to insert elements into the queue, we can use the offer method. Here you can see queue has maintained the insertion order of elements. We can use the poll method to remove the elements from the other side of the queue. In this case, that will be the front of the queue. Here you can see after calling the poll method, the first element has been removed from the queue. It is not possible that you can directly access any element inside a queue. There is no get method in the queue. There is a special method in queue interface called peek. Peek method does not modify the queue, but only retrieve the first element inside the queue. Here you can see the peek method returns the first element inside the queue. The fourth and the final Java interface that we are going to learn is the map interface. Map interface provides a data structure of key value pairs. Inside a map, what we find is a key and an associated particular value. So we have multiple of these entries inside a map representation. It is also possible by providing a particular key, we can directly read the associated value from that map object. Let's create a map and then store some data and try to understand the map concept. Let's import this map interface from the java.util package. If you can recall, the Java collections framework is made out of 4 different pillars, and those are list, set, queue, and map. All of those 4 are actually Java interfaces. Therefore, it is not possible that you can create an object out of a Java interface. In this case, the map is an interface. Therefore, you cannot use the new keyword and try to create an object directly out of a map interface. So what you can do in this case, you can create an object from a class that has implemented the map interface. HashMap is such a class that has implemented the map interface. You have to import this HashMap from the java.util package as well. Now, let's try to insert or store some data inside this map object. In the map interface, we do have a method called put, where we store the values or insert the values into the map object. In this case, we must provide the key and the associated value that has to be stored together inside the map object. Here you can see the representation of a map is within a curly brackets, we show the key value pairs separated by the comma. Just like the other collections that we have learned so far, we can utilize the diamond operator and specify the type of the keys and type of the objects as well. In this case, I have restricted or limited the keys has to be with the type of string objects, and the value that is being associated with that key has to be the integer object. In the second put method, now I am actually violating that restriction. Therefore, this will not compile. Let me fix that. It is possible that we can retrieve a value by providing a key. In this case, we can use the get method. Whenever you are using the get method, you must provide the key. If you try to provide a different key or non-existing key, you will not receive a value. Instead, you will receive a null reference. You can also remove a pair by using the remove method. After removing that key value pair, I'm only left with a single key value pair. In order to read all the values inside the map, you can utilize the entry set method. Entry set method gives us all the entries inside the map. In this case, what I'm doing is I'm looping or iterating through all those entry set objects inside that map object. It is completely fine that the key to be null inside a map. Now you have a good understanding about the Java collections framework. However, if you want to have some extended capabilities, you can consider these two alternatives. For example, Apache Commons collections and also Eclipse collections. They are open source libraries. You can include them in your Java projects and use those extended enhanced collections they are offering. Alright, my dear students, since we came to the end of this video, I want to summarize about what we have learned together. We started off understanding about the default values. Then we also understood that for every primitive data type in Java, there is a corresponding wrapper class. We also understood how the auto boxing and auto unboxing can happen. We also took a moment to understand the concept of arrays and how to create arrays in Java. Later, we discuss about the collections framework. It is built upon 4 different pillars in Java. They are list, set, queue, and map. We also had few examples to understand these 4 interfaces and their implementing or concrete classes that we can use. So, now I believe it is the perfect time that you take some time off and try out few different examples using data structures and also arrays that cannot be taught by someone else. Therefore, take few minutes to try out few examples by your own, and then it will remember for the rest of your life. Also note that data structures are not the solution for every problem. Sometimes some problems can be solved easily by using variables and arrays. Now you are in a very good position to learn about Java Lambda expressions. Therefore, I invite you to join with me where we are going to learn about Java Lambda expression in my next video. Thank you.